Circuit analysis, electrical circuit analysis subject, delta or connection balance load problem, and formally discuss in this video. Circuit analysis subject, delta connection balance load, three phase, problem number 13, seen in length, question and answer. In this class, we see solution that problem, balance load delta connections. Class number 172. A three-phase balanced delta connected load of 4 plus J8 ohm is connected across a 400 volt three-phase balanced supply. Determine the phase currents and line currents. Assume the phase sequence to be RYB. Also calculate the power drawn by the load. Previous classes or previous video I explained formula of balanced load delta collections and model circuit diagram. Delta connections balanced load circuit diagram are given in previous class. This page see model circuit diagram. I1, I2 and I3 are the line currents or YB or phase. Class number 172 Advanced Engineering. Solution. Referring the figure model taking the line voltage VRY is V angle of 0 degree as reference. I already explained in previous classes. So VRY is taken 400 angle of 0 8 volts. VOB is 400 minus 128 volts. VBR is 400 angle of minus 240 degree in volts. Impedance per phase is 4 plus J8 ohm. That is changed into impedance complex algebra to polar former. 8.94 angle of 63.4 degree using calculator. I already explained previous classes how to change this complex algebra to polar former. Phase currents are IR is previous classes explained formula is VRY angle of 0 degree divided by Z angle of phi, E by Z angle of minus phi. That is answer. Put required values 400 angle of 0 degree divided by 8.94 angle of 63.4 degree. Answer IR is 44.74 angle of minus 63.4 degree in ampere. IY is VOB angle of minus 120 degree divided by Z angle of phi. That is V divided by Z angle of minus 120 degree minus phi. That is already known that formula. Put VOB is 400 angle of minus 120 divided by 8.94 63.4 angle. We obtain IY value is 44.74 angle of minus 183.4 degree in ampere. IB is we already known formula. VBR angle of minus 240 degree divided by Z angle of phi is V divided by Z angle of minus 240 degree minus phi. That is formula. Put required values. IB is 400 minus 240 degree divided by 8.94 angle of 63.4. Answer IB is 44.74 angle of minus 303.4 degree in ampere. Important points is the line currents are root 3 times the phase currents and are 30 degree behind the respective phase currents. 30 degree is very important using line currents formula. I given tabulations for delta connection balance load. I1 is phasor difference of IR minus IB. Root 3 modulus of B divided by Z angle of minus 5 minus 30 degree. I2 is phasor difference of IY and IR. That is IY minus IR root 3 modulus of B divided by Z angle of minus 120 minus 5 minus 30 degree. I3 is phasor difference of IB and IY or IB minus IY. I3 is root 3 modulus of V divided by Z angle of 240 degree minus 5 minus 30. First model we find out line current phasor difference of IR and IY, that is IR minus IB. 44.74 angle of minus 63.4 degree minus 44.74 angle of minus 303.4 degree. Using calculator we find out that answer is seen in next page. I1 is 77.49 angle of 263.6 degree in ampere. Second model, then go to line current calculator. with using formulae. Previous class I explained. Compass algebra to polar method I explained in advanced link. Kindly use this classes. Complex algebra to polar format, how to form polar format. I1 is root 3 modulus of V divided by is an angle of minus 5 minus 30 degree. Using that formula, root 3 into V divided by Z is 44.74, angle is minus 63.4 minus 30. Only we find out 77.49 angle of minus 93.4 degree, that is second model. We choose any model, find out line currents, phasor difference, or using formula is it V divided by Z and with angle formula using two methods using find out line currents I1, I2 and I3. Similarly, I2 is IY minus IR, I3 is IB minus IY, I2 formula is root 3 modulus of V divided by S angle of minus 5 minus 150 degree, I3 is root 3 modulus of V divided by S angle of minus 270 minus 5, put V divided by Z modulus value is 44.74. Previous page I given family put record values. We have an I2 value is 77.49 angle of minus 213.4 degree ampere. I3 value is 77.49 angle of minus 33.4 degree ampere. In this tabulation I given first model and second model answer. We get answer any model. Power drawn by the load is P is 3 VPH IPH cos phi or P is root 3 VLIL cos phi. Put record values. Phi is 63.4 degree angle. Put record values in that power formula. We find out power drawn by the load is P is 24.039 in kilowatts. That is problem with solutions. Delta connections 3 phase. Madam Engineer, thank you.